Is 3-3. Today is your last day to retake 2-5 through 2-8. Must be done at interventions if you're planning to do that. And last day to do anything else you can to get your grade up. As I am leaving and my final grades are going in for the quarter tonight. Okay? All right, so 3-3 is solving systems of equations using the substitution method. Substitution method is you solve for one variable and you use what you found that variable equal to and substitute it in for that variable in the other equation and then solve. This process works the best when you're given a problem like this one, or you're given a problem that one of the equations is a y equals something or an x equals something. So you don't have to do a lot of work to figure out what one variable is equal to substitute into the other. Does that make sense? So we've learned how to solve systems by graphing. This is going to be substitution. Tomorrow is elimination. You're going to learn the elimination method. All three of them work. If you do all three of them with the same system, you'll get the same answer. But as you progress through, you're going to start seeing what the easiest way is to solve. If they're both in standard form, using the elimination method is usually easiest, unless one of the variables has a coefficient of 1, like this one, because these are both in standard form, right? But it just takes one step to solve for y. Y equals negative 2x plus 12, right? And then I can use that and substitute into another. And I'll do an example or two when we're finished. But for tomorrow, you'll hear, after you do the textbook check for 3-4, Mrs. Fennell's going to play the video that I recorded last year on 3-4. So if there's anything in that video that pertains to last year, dates and times, just disregard that because it's not pertinent to this year. But the information will be the same. Okay? All right, so before I jump into the textbook check, let's look at those equations we were looking at yesterday as an example. If I'm told on a test that you must use the elimination method, then you have to use the elimination method. Okay? If you can get, why is Kate calling me? Hello?
Hey.
I'm in the middle of talking to my class.
Okay, no.
No, is it something urgent?
I was wondering a couple things if you could log in this office.
Okay, I'll have to do that in just a little bit. Okay, bye. Okay, so as I was saying, if I ask you on a test to solve this system using substitution, then your work must show you solving it using substitution, even if elimination is easier in this particular problem, which I think it would be. But let me show you how to solve this using the substitution method. Okay? And what I'm going to do is pick a y that's easiest or an x that's easiest for me to get by itself. And I might even just use 2x. Okay, so I don't have to solve it for y. I can solve it for x. It doesn't matter. So to solve this for 2x, y is my board. Don't know. 2x equals 6 plus 3y. Everybody see that? I just added the 3y over. And now I'm going to divide everything by 2. So x is equal to 3 plus 3/2 y. Follow me so far? Okay, so now I've solved the system for one variable. Now in the other equation, I've solved an equation for one variable. Everywhere I see an x, I'm substituting, this is where the substitution method comes in, I'm substituting what x is equal to with something with y. So instead of negative 4x, I'm going to make this negative 4 times 3 plus 3/2 y, because that's what x is equal to. Make sense? Okay, so now I'm going to go ahead and distribute my negative 4. I'm going to do it down here. Negative 12. What's a negative 4 divided by 2? Negative 2 times 3 is negative 6. And that's what I get. So my negative 6y plus 6y goes to 0, right? And I'm left with negative 12 equals negative 12. Okay? When you solve systems, you're going to get one of 3 types of answers. You're going to get an answer that says x equals something and y equals something, single point. You're going to get an answer like this, a number is equal to itself. Or you might get an answer like this, a number is equal to a different number. Okay, so my first type of answer might be like this. Maybe I got x equal to 1 or y equals 1. Then I would take that number and substitute it back into the original equation and find what y is. That would be an actual point as my answer. But these two don't look like normal answers that we see. What it tells you, if it's a true statement, if negative 12 is in fact equal to negative 12, is there any time it won't be? Is there any time negative 12 will not be equal to itself? No. What it tells you is there's unlimited solutions. Every point, there's infinite number of solutions. What that means is those two lines were the same line. We talked about this yesterday. If I go back up to those two lines, I had negative 4x here. Remember we said from 2 to negative 4 is times negative 2, right? Negative 3 to 6 times negative 2 is 6, right? Negative 3 times negative 2. And 6 times negative 2 is 12. These two lines are the same line if I graph them. So when I solve them algebraically and I get negative 12 equals negative 12 or 0 equals 0 or 6 equals 6 as my answer, all that tells me is those two lines originally were the same line. And if you graph the same line, don't you see that every point those two lines cross are solutions? That's why there's an infinite number of solutions. Okay? So graphically, to solve this system, I would have graphed these two, and I would have seen that they were in fact the same line, and my answer would have been infinite number of solutions, which would have been consistent, because there's at least one solution, and dependent, because there's not exactly one solution. Consistent, dependent, if they're the same line. Okay? If we go down to our answer, and when we finish our math algebraically, and I get this, or any other kind of answer that makes no sense, 1 equals 3, 7 equals 10, that tells me those two lines started out as parallel lines, and there's no solution, which makes sense. If 6 equals 12, makes no sense. That's not a solution. So those two lines that I started with have the same slope, but a different y-intercept. And so when I get algebraically, I get an answer at the end that makes no sense. 6 equals 12. That tells me it's no solution, and those lines originally were parallel. And parallel lines are inconsistent because they have no solution, not even one answer. Okay? If I end up getting a single point, that means those two lines intersect at a single point. They aren't parallel, they aren't the same line. They have a different slope, they have a different y-intercept. So they actually have one solution. Okay? And that solution is whatever you find x and y to be. Okay? So let's look at that first example and just solve it using substitution. 2x plus y equals 12. And I'm going to use blue. And negative 3x minus 5y equals negative 11. So yesterday, we could have graphed these two and then seen on the graph where they intersect. We could have done that. Today, we're going to learn how to do it algebraically using the substitution method. So when I see a problem like this, using the substitution method, I know my goal is to solve for one variable in one of the equations. So I'm going to pick the easiest one to solve for. What would that be? That first equation, and what would I try and solve for? You said x, you said y. What do you guys think? You'd say y? Yeah, it's probably easier to solve for y because all I have to do is subtract 2x. If I have to solve for x, I have to subtract the y and then divide by 2. So it's 2 steps. So I'm always looking for, we should all be looking for the easiest way to do math. Should be our goal. Okay? So when I look at this, yes, I'm going to pick the first equation to solve, and I'm going to pick y. So I'm going to solve the first equation for y. And I get this. Okay? Now, I'm going to substitute this in for y here. Okay? So I'm going to get negative 3x minus 5 times negative 2x plus 12 equals negative 11. The most important part when you're doing the substitution method is to take your time and to put parentheses around the expression that you're substituting for to make sure that you're distributing whatever the coefficient is in front of that into it. If you are in a rush and you don't put parentheses around it or you forget to distribute, you're going to miss the whole thing. And we don't want to miss the whole thing. Okay, so I just rewrote this equation, negative 3x minus 5, and I substituted what I found for y up here, negative 2x plus 12, in for y. Now I'm going to solve, maybe. Come on, board. I don't know what that original number was. 3. Y is giving me fits today. Okay. So I'm going to write negative 3x, except that doesn't need to be simplified yet. I'm going to distribute the negative 5 in. So what's negative 5 times negative 2? Positive 10. Negative 5 times 12, negative 60, equals negative 11. So I have negative 3x minus 50 equals negative 11. Add 50. Negative 3x equals 39. Divide by negative 3. X equals what? Negative 13. So now I've found my x coordinate of the solution. But I need both. I need a point for the solution. So what I'm going to do is I'm going to take negative 13 and go back to my original equations. I can choose either one. Doesn't matter. Whatever's easiest. I'm going to choose the first one. And I'm going to substitute negative 13 in for x and solve for y. Okay? So 2 times negative 13 is negative 26. Add 26. And y is equal to 38. So my answer is negative 13, 38. Okay, how could I check it? Yeah, plug it in. I'm going to pick this one, plug in my answer, and see if it's true. Because it should, if it's true, that point should satisfy both of these equations, because that's where these two equations intersect. So if I put in negative 13 times negative 3 is 39, minus 5 times 38, something doesn't seem right, equals negative 11. So what's 5 times 38? Did I do that right? Yep. 115, 119, or 19. So 39 minus 190 is definitely not negative 11. So at this point, this is why it's important to check. You need to go back and figure out where you messed up, okay? Because it happens even to your teacher, which is okay. But that's why it's important to check, because you get the answer, negative 1338. If you don't check it, you're going to miss the whole problem, because you did something wrong and you don't know it. Okay, so let's figure out where we messed up, where I messed up, because you guys weren't helping me at all, obviously. Okay, so the first thing I did is I solved for y, and I got y equal to negative 2x plus 12. I plugged it in for y in this equation to get negative 3x minus 5 times negative 2x plus 12 equals negative 11. Aha! What's negative 5 times negative 2x? This is why it's so important to check, because there's so many places you can mess up here that if you don't check your final answer, it's going to be wrong. A lot of times, not all the time. Okay, so now I have negative 3x plus 10x, 7x minus 60 equals negative 11. I'm going to add 60. Okay, and I get 7x equals what? 49. Is that right? 50, 49. Divide by 7. X is not negative 13. It's actually 7. Okay, now I'm going to plug that back in to this mess that's up here, or here. I'm going to use this one. 2 times 7, 14. So I have 14 plus y equals 12. So when I subtract 14, y is equal to negative 2. Right? So my point should be 7, negative 2. Well, let's check it on the second equation. Okay? Negative 3 times 7 is negative 21. Keep doing that with my hand. And negative 5 times negative 2 is plus 10. Is that equal to negative 11?
Yes.
Yes. So my answer is 7, negative 2. See the importance of checking your work? Yep. Okay, so elimination or substitution method, you're going to solve one equation for one variable, substitute it in for that variable in the second equation, solve for the variable that's left. Once you've found that variable, you're going to take that number and put it back into one of the two equations, doesn't matter which one, and solve for the other variable. Final step, check your work and make sure that solution satisfies both equations. Okay, so let's look at the textbook check. When using the substitution method, we just went through this one. The first step in this example would be to solve for y in the first equation. There are other ways you could do it, but that's the easiest way. Pick the variable that's easiest to solve. Question 2. If you solve a system of two equations and get 0 equals 0 for your answer, this means what? I just went over that with the negative 12 equals negative 12 example. Huh? No? Is there ever a time that 0 won't equal 0? There's infinite number of solutions. Your answer is infinite. If you solve a system and get 0 equals 0 for your answer, if there are infinite number of solutions, what does that tell you about the two equations? They're the same line. So if you ever get 0 equals 0, 6 equals 6, 7 equals 7 for your answer, it tells you there's infinite number of solutions, and those two lines you started with are exactly the same line. One's just multiplied by a factor of the other. Okay? If you get 6 equals 12 as an example for your answer, it tells you those lines are parallel and there's no solution because those lines will never cross. And the solution is where the lines cross, which is why if it's the same line, they cross everywhere for infinity. There's infinite number. If they're parallel, they will never cross, so there's no solution, which makes sense. 6 will never equal 12. Not possible, no solution. Okay? Question 4. Maybe. If you solve a system of equations and get the point -3,7 as the solution, how would we classify that? What does consistent mean? What does consistent mean?
Stays the same.
Okay, in English, that's what it means. What does it mean when we're talking about systems of equations? What does consistent mean? Consistent, a system is consistent if there's at least one solution. So a system that crosses at one point is consistent. A system that's the same line is consistent because there's at least one solution. A system that's parallel, not consistent, inconsistent. Okay? So if it's 3, -7, -3,7, there is at least one solution, so it is consistent. Okay? The other one, dependent or independent, it's independent if there's exactly one. Okay? So this one, there is exactly one solution. So it is consistent and independent. It's dependent if there's not exactly one. So the same line is going to be consistent because there's at least one, but dependent because there is more than one. Okay? And then parallel lines, just inconsistent. Okay, so the answer here was consistent and independent. The presenter who watched the video, James Souza, the yellow, kind of light yellow background. Yep. Okay, do I need to do another example of a substitution problem? Would that be helpful to anyone, or do you just want to jump in and try some on your own? Okay, I'll take that as jump in and try some on your own. Okay.